In this video, we will see JK flip-flop. JK flip-flop characteristic is similar to SR flip-flop. This J input is equivalent to S input of SR flip-flop and K input is equivalent to R input of the SR flip-flop. That is, J will act as a set input and K will act as a reset input. And already we are having SR flip-flop. Here the characteristics same. Why we go for this JK flip-flop? There is one drawback in SR flip-flop. That is, when both the inputs are 1, it gives the invalid output. That is, Q and Q dash is equal, which is invalid. This problem is resolved in JK flip-flop. So in JK flip-flop, if both the inputs are 1, it will give the valid output. So when J and K is equal to 1, the flip-flop output toggles. So this is the logic diagram of JK flip-flop. Actually, this circuit is SR flip-flop. J, that is S, here R. In addition to this S and R input, we are giving one more input which is taken from the output, previous output. Q dash is given here, Q is given here. Then it becomes a JK flip-flop. Now we have to replace S by J and R by K. So by small modification in SR flip-flop, you get the JK flip-flop, and this is the logic diagram of positive edge triggered JK flip-flop, which has two inputs J and K and two outputs Q and Q dash. J input is a set input, K input is a reset input. So the operation is same as SR flip-flop. When J is equal to 1, it will set the flip-flop. K is equal to 1, it will reset the flip-flop. When both the inputs are 0, then it will remains in the same state. Both the inputs are 1, it toggles the output. Next, we will see the characteristic table of JK flip-flop. It is similar to SR flip-flop except the case when J and K is equal to 1. 0, 0, it remains in the same state. 0, 0, 1, K input is 1, reset. So it will reset the flip-flop, clear the flip-flop. So output is 0. 1, 0, J is 1, it will set the flip-flop. So next state is 1. 1, 1, it will toggle the output. So the present state is toggled. Toggle is nothing but you have to take a complement. So it will complement the present state. 0, here you get 1. 0, 0 remains in the same state. So you get 1 here. 0, 1, reset input is 1. So clear the flip-flop. 1, 0, set input is 1. It will set the flip-flop. 1, 1, toggle the present state. So you get 0 here. This is the characteristic table of JK flip-flop. And this all the condition is possible only at the positive edge of the clock, because here we are using positive edge triggered flip-flop. And next one, to derive the next state equation, you have to draw the K map. Here there is 3 input, present state, J and K. So draw the 3 variable K map. And the next state is 1 for min term 2. So put 1 here. Min term 3. So 1. Min term 4. So 1. And min term 110, that is 6. Min term 6. Next one is grouping. These two ones are adjacent to each other. So you can group these two ones. Then the corresponding term. It involves first row. Here Qn is constant and the value is 0. So Qn dash. It involves third and fourth column. So in this third and fourth column, first variable J is constant and the value is 1. So J. And here you have 1, here 1, here adjacent. So you can group these two ones. It involves first and last column. Here K is constant and the value is 0. So K dash, and it involves second row where Qn is constant and the value is Qn. So Qn plus 1, next state is equal to J Qn dash plus K dash Qn. So this is the next state equation of JK flip-flop. Next one, excitation table. Here you have to find the excitation input of that flip-flop by knowing the value of present state and next state. For this, you have to refer the characteristic table. If Qn is 0, Qn may be 0 or 1. Qn is 1, Qn plus 1 is maybe 0 or 1. Or you can write the all four possible combination for this two variable. So first condition 0, 0. So here present state is 0, next state is 0, present state 0, next state 0. In that case, you have to check the input. J0, K is 0, first case K0, second case K1. So you can write J is equal to 0 and K is equal to X. X means it may be 0 or 1. So for the first condition, 0, 0, your J value is 0, K value is X. Second condition 0, 1. 0, 1 and here 0, 1. So here you have to check the inputs. J is equal to 1 and K is equal to 0 and 1. So you can put J is 1 and K is X. So J1, K is X. Next condition is 1, 0. Here you get 1, 0 and here 1, 0. In first case J0, K1. Here J1, K0. So in both the cases K value is 1. So you can write J is equal to 1 and K is equal to X. So here J is X and K is 1. Last condition 1, 1. Here 1, here 1, right? Here 1, here 1. Here both the inputs are 0. Here 1, 0. That is K value is constant 0 and J value is 0 and 1. So you can put J is X and K is equal to 0. So X 0. This is excitation table of JK flip-flop. Next we will draw the state diagram. There is two states. So represent that states within the circle. So there is two states 0 and 1 here. Present state 0, input is 0, 0, it remains in the same state. 0. Input 0, 1, again you get the same state. 0, 1 also you get the same state. Input is 1, 0, then it moved to 1. Present state 0, input is 1, 0, then it moved to 1. So input is 1, 0, it moved to 1. Present state 0, input is 1, 1, it moved to 1. So here 1, 1 also it moves to 1. Then present state is 1, input is 0, 0, it remains in the same state. So 0, 0. If input is 0, 1, it goes to 0. 0, 1, it moved to 0. 1, 0, it remains in the same state 1. So here 1, 0, it remains in the same state. Then 1, 1, then it moved to 0. If present state is 1, input is 1, 1, it moved to 0. So 1, 1, then it moved to 0. This is the state diagram of JK flip-flop.